if you're done with your 0 to 1 and you are scaling from 1 to n, that's where we work. And that's where Gautam and I, we were discussing a lot of work that we have done around scalability, performance, optimization of systems, databases, reliability, etc. So we're going to talk about all of that today. That'll be fun. Excited to understand your point of view, your challenges. If we can help all as a panelist on understanding and answering your questions, that will be super useful. So looking forward. Thanks.
Hi everyone, I'm Harman. I am a developer at a company called Tarka Labs. We are into software consulting, and I have been coding for close to 11 years now. Go obviously is not my first language as with everyone else, so I started with Ruby, and then I just knocked the doors of Go whenever I have to do something on scalability, concurrency, and these things. My primary domain, at least for the past few years, has been into music tech. I've been involved a lot of music distribution across the various stores in the world, and then the royalties and all the analytics side of things, where I got introduced to different types of databases and things. And at Tarka Labs, we are always hiring. So if anyone is looking out for a job or something, please feel free. Yeah, thank you.
Hi, my name is Prerath Manjal. I am the co-founder and CTO of KubeCloud. So we are building a no-code platform for cloud native ecosystem, come marketplace. So more about my platform later on. So today we will be discussing about scalability. So I did around 500 terabytes of migration from AWS to GCP. So it's about the journey that we followed, that we faced. And also I love to travel. So in the past 12 months, I've traveled over 10 countries. Yeah.
Hi everyone, I'm Shailesh Patil. I'm a co-founder and CTO at Quick Insure. So we are a Pune-based insurtech company primarily operating in insurance distribution. We have a tech platform which is enabling all the agents in the market who can book the policies of all insurance, like motor, health, PA, travel, everything. So on one side, we have almost around 50,000 partners, and on the other side, we have 30 plus insurance companies. Our intention is to, take the tech at the grassroots level where, the agent doesn't have to go to the office of any insurance companies for any policy issuance. So the recent example is, we have got a cattle insurance where, that we have done end-to-end integration. So any farmer can approach the agent and book the cattle insurance policy. So at a personal level, I have around 17 years of experience, primarily as to work in Ruby. And then we moved to Go for wherever, we had a scaling issues. That's it.
And I am Gautam Rege, Josh Software. We build products for scalability and performance for customers like them. All right, so without further ado, I heard Prerath mention 500 terabytes. Let's talk about scale. Let's talk about data migration. What were the initial problems that you faced, Prerath?
So a quick recap. Okay, so I am from the cloud and infrastructure background. Okay, so I'm a little bit less on Go side, but this is the story where I actually involved my entire company in Go. So the problem statement is that we provide abstractions. Okay, so we provide reliability abstraction, we provide storage abstraction. So this was a story about an abstraction that we provided to the photographers. Okay, the wedding photographers, the videos, the music audios, okay, the relatives dancing on the floor, okay, and some fufa making some face, okay, while eating. So the problem here was that as I said, that we provide abstraction layers to the various, not just photographers, but also events like these, okay, the CNCF events, the Linux Foundation events. So I'm very much active there, and we provide abstractions to nearly all of the events part as well. So the problem was that in the beginning we had 500 terabytes of data and on AWS, and we just had 15 days to actually migrate from AWS to GCP. Why GCP? Because first is that we got a lot of credits, and second thing is that I have very close connections with people at Google. So somewhat customer support was very much aligned with us. They gave their best to us so that we can migrate easily. But the problem here was that if you know how to migrate from AWS to GCP, there are a couple of services. First is the Sphere or the transfer appliance. Okay, but for that actually you need to go through a loop, okay, which takes another 15 days or 10 days because you need to submit a lot of documents to them. So obviously it was not an reliable option, or not even close to the right option that we were looking for. The second was that there is something known as transfer service. Okay, Google has a different transfer service where you can just add some SSH keys and then you can transfer the data. But the bottleneck here is that they provide at max 1 Gbps, okay, and which could have taken us around 31 days, even if we run multiple transfer services along the loop. But we were only having 15 days, and I was not that much confident in Go. But some of our interns, okay, or some of our founding engineers told us that Go is a very concurrent language. You can build pipelines. There is something known as Go routines. There are channels. So then we did a quick prototype POC where we migrated around 10 GB of data, and we built custom controllers. We had Go routines in place. We had channels. So the initial architecture was that the metadata and everything was stored in AWS, and S3 had all the objects. And then we built custom controllers where we would fetch the metadata, and then we would pass the metadata to the worker nodes, which would indeed fetch the S3 objects and then upload and then do the checksum, okay, just to make sure that the objects were not corrupted. So MD5 or E-tag version, we just checked after uploading it to the GCS buckets, and then we had a fallback topic, okay. So in case if something was not migrated to GCS or we were lacking the total count of the objects in a particular folder, then we would just run a loop and just make sure that these are the actually migrated objects.
So Prerath,
Yeah.
the entire process took a month?
No. So the entire process took around 2.5 days. Okay.
Instead of 1 month that you all thought earlier,
it's 2.5 days.
Got down to what were the key factors, the 3 main key factors for increasing the scalability to finish such a large, you said 500 terabytes of data, large video file data from a month to 3 days? What are the 3 key things?
Okay, so the entire Go is about concurrency, right? So we were even shocked that there were no open source solutions based on Go just for this simple task, right? So see, the 3 things were parallelism, right? And second was we already had one intern who knew Go, okay?
And I like the way you mentioned interns and founding engineers. That's pretty cool.
So 3, I think the entire event is about Golang, right? What Golang offers. First is concurrency, right? And that's why most of the, even Kubernetes, even Docker, even most of the CNCF tools are based out of Golang, okay? So
was there something that was modified? Because I remember, Chinmay, you mentioned about migrating data yesterday in a flash talk. So using concurrency and using a lot of channels. And I think you had also mentioned in your talk, if I may remember in my zonked out state, that there were some issues with that too.
Yeah, actually I had channels. Yeah. So I was coming to it, okay? So So the thing that during the migration we saw that so there is something known as channels, right? We know. So there is initially some bottlenecks around channels. So we were actually increasing the number of cores just to make sure that our migration took just 24 hours or maybe 35 hours, okay? Because it was Friday and we didn't want it to linger on till the very next Monday or Tuesday. So we were just increasing the number of CPUs, the number of cores actually. But there is some bottleneck regarding channel that if you increase the number of cores above 55 or 65, the performance of channels degrades, okay? So this is because due to the Golang's actual code base, there is some in channels in the backend processes, they apply logs, okay? So not like mutexes.
Hang on.
Oh, yeah.
Hang on there. Let me reiterate what you just mentioned. After using 50-60 cores,
Yeah.
your channel your number of Go routines that you spawned,
Yeah.
and the channels that you spawned
No, actually they
had a problem.
Yeah, problem. Yeah.
For bottleneck.
Yeah.
Chinmay or somebody else, what are your thoughts on this? Because otherwise I do.
I don't think that 50-60, just the number of Go routines will make a difference. It's about the resources probably, right? Maybe you're using some memory or certain CPUs, and that because 50-60 seems a little less as compared to like how we have been talking about channels.
50-60 cores.
Okay.
50-60 cores. If you are taking, and how many Go routines would have been spawned in this?
So we had around 20 worker nodes. So the configuration was like N2 high mem and number of cores were around 64. Okay, but initially it was 128, N2 high mem 128 with 1.5 terabytes of external SSD attached to, and we were having around 10 to 20 worker nodes, right? And then so we learned that the channel's performance degrades after 60 cores, okay? 60 or 50 cores. We actually didn't have that much time to find the actual number of CPUs. But later on, when we searched it on Google that why this is happening, okay? Then a lot of people also face the same issues that if we increase the number of cores after 75 or 65, again, they also didn't have that actual number. The performance was degrading, not actually increasing.
Interesting. Yeah. Chinmay, you're the concurrency parallelism person, so you're itching to speak.
Yeah. So, I mean, what I want to talk about in general is data migration, for example, in this case, right? If you think data as bunch of files, that is a massively parallelizable operation fundamentally, meaning one copy doesn't depend on other copy fundamentally, right? So what you're going to be bottlenecked on ultimately is network throughput, right? If your network throughput is, say, you're able to transfer 100 gigs or 10 gigs a second, you will take that much time ultimately, no matter how many Go routines you run, what other fancy algorithms you use, etc. Ultimately, your network pipe, especially if it's a internet to internet transfer, right? That's what you'll end up with. This is kind of one interesting use case we talked about. There's one more which I want to talk about, which is about stateful data. Meaning, stateless systems are pretty easy to manage. You can throw more hardware at it and it will scale linearly. For stateful systems and managing and migrating that, there's the queuing theory concepts kind of come into picture, things like Amdahl's law, right? For example, what it means is that there are only some parts of the system that can be parallelized, and you get good improvement in terms of performance if you parallelize that parts of the system. The remaining parts are anyway going to be sequential. So no matter what you do, you will not be able to parallelize that part, right? And then it talks about, I think the 50-60 Go routines performance problem that he's talking about will probably refer to another thing called universal scalability law, which says if you have more number of Go routines, there is going to be more coordination effort among them, right? And that's where the bottleneck could occur, where at some point you are going to reach and have too much chatter between Go routines or schedulers so that they are scheduled on the OS process, right? That's something that could be one of the challenges.
So the other thing about scalability is, especially when you're working the large number of Go routines, is idempotency. I remember us having some discussion, Harman, about idempotent tasks. So maybe you want to speak a little bit about that too.
Sure. So my use case was slightly different. So I was working with financial records at one point. And idempotency, becomes really important in case of financial records because you cannot end up paying someone twice, right? In that case, at least, so my use case was more on the ETL side of, thing, where I was more involved in the transformation layer at one point. But the whole goal there was that, how I see concurrent systems is that you should not aim for concurrency from day one, right? You aim for concurrence, you aim for the logic to work end to end, and then divide that into different blocks, and then try to make each block in parallel, right? Instead of saying that, let me just start with concurrency, because debugging an application becomes really difficult. And when you divide this thing into batches, the smaller batches, each of the batch has to be idempotent, because one good or bad thing about software is that it can fail at any time at all, right? So I was actually listening to a talk by someone. They were saying that my system was foolproof, it could not fail ever, but they said that my server caught fire. Now, that could happen, right? So you cannot say that your code is fail-safe. It can fail at any point of time. So you need to make sure that if you are breaking in between, and that's where the whole transactions and rollbacks kind of things come into the play, because if anything goes wrong, you should be in a position to start from the very beginning. And the other good thing about this is that, if you're saying you have to start from the beginning, you need to make sure that your workers are small in size, right? You cannot be doing huge tasks. Like in your case, you were saying you were transferring, let's say, 500 TB. Let's say if I have a single job transferring 500 TB, if it fails after 300 terabytes of transfer and I have no way to start from, let's say, a checkpoint or a milestone, then I'm gone. I have to start from the very beginning because I don't know which file has been transferred half, which file has been transferred full. And that was the same case, at least what I've faced during the financial transactions. So if I pay out the user, I have to either pay them in full or not pay them at all, right? There was no middle ground as such in between. And keeping the workers small actually helped us, and that helped us parallelize things as well pretty fast.
And along with such kind of idempotency, resilience, failovers, and failbacks, Shailesh, your systems in the same financial domain, he's in the financial domain, in the insurance space, you would probably require very fast updates for large amounts of data. What are your thoughts on that?
So in our case, what happens is like any agent or any person who is working with us expects a commission out of it, right? Why they want to work for free? So when we started, we have even right now we have a plain Ruby stack. And initially when we wanted to update these commissions, the first thing is you do it in Ruby. Right? At that point of time, probably 3 years back, it was a very simple commission structure that, you have this vehicle, this RTO, and the commission this is the commission. But as the competition starts increasing, we started seeing that the commission structure is getting complex. That's when, the file where we used to update the commissions, it has started increasing. So initially that file was around 4 to 5 MB. Now it has crossed around 200 MB. So when you used to update in Ruby, obviously it used to take a lot of time. Then we started looking at different parameters and alternatives where we can upload. And that's where we started with Go. So one thing I've realized is, like Haman said, we can have n number of Go routines. We can have the hardware also in place. But you will always face the latency at where you are dumping the data. So in our case, we used to earlier dump it in MongoDB. But then MongoDB has certain limitations. Then we moved to Elasticsearch. So now with the combination of Go and Elasticsearch, plus we are using bulk index and all, so now it has come down to, if you have to update the pricing at any point of time, it takes hardly 20-30 seconds.
So that's interesting. A factor of performance and scale is actually the storage, which could also be a point of contention for deciding what is the right tools to use. And we've already gone through a talk from Sarthak earlier about different claims for databases and different types of database to use in different use cases. In your case, Prerath, what was the storage that you were using, which actually helped you out, and what was the choice?
So one issue that I forgot to mention is that one bottleneck again was of rate limiting. Okay, so if you have any workload on cloud, everything is behind quotas. Okay, so how many of you know about HashiCorp and Terraform? Yeah. Okay. Who is from HashiCorp? Okay, so so recently I gave a talk. So recently I gave a talk at Hashi Days Sydney. Okay, with Arman Ladgar. So there actually what happened was, due to rate limits, we faced a bill of $1 million. Okay, $1 million, and similarly we were hitting the rate limits set by cloud vendors on the GCS part. Okay, there are some call, like, you can't make more than 10,000 writes to a single bucket, and again the same applies to different regions, different zones. So make sure to check that rate limiting video out. And similarly we faced the same issue in Google Cloud, and we were again blocked by Google Cloud. Then we made a call, then the rate limits were lifted up. Yeah, so what was the question?
I like that. I forgot my own question. What kind of storage were you using to ensure that you had seamless migration for large files across clouds?
So for AWS we had S3, and for Google Cloud we had GCS buckets. Okay, and for metadata we were using Bigtable for storing the metadata in Google Cloud. And yeah, that's it.
I think a database or data store makes a lot of difference in the kind of speed that you can get in. So I have like a couple of stories regarding this. So one was that we were actually using MariaDB, and our use case was in the ETL side. We had to import a lot of data into the database. So I had files as big as 50, 60 GB, and we usually use the load data in file command to load that into MariaDB, and then we had to do some transactions on top of that. So that piece itself used to take around 3 to 4 hours, because we had all these indexes and things to make sure that if anything goes bad in between, we need to make sure we can just start from where it left. So in that case, we actually moved over to an analytical database called ClickHouse, which kind of improved the insert speed pretty much. So from 4 hours, I got it down to, let's say, 10 to 15 minutes. And then on top of that, given it was not a transactional database, we could not do all the transactional queries, but that was actually used to build a smaller file, which could be then imported into something like MariaDB, right? Instead of importing the whole 50 GB file, we were importing a smaller size file, and that kind of improved the speed that we were working with. And the second thing, which I think Sarthak also mentioned in his talks regarding PebbleDB and RocksDB. So we were actually using PebbleDB for one of our use cases, which is pretty much a key value store that we can have in memory. The use case which it helped was that we were actually using Redis, and we ended up using the Elastic Cache from AWS. And we were actually doing it to do some matching algorithms. But the thing about that was that we were actually doing a network call, which kind of added latency. But PebbleDB being like in memory or on the disk thing, there was no latency involved. And then with the speed we were able to read and write. That kind of helped improve our process pretty much. And then whatever we were doing in Ruby using MariaDB queries and without ClickHouse, let's say in 8 to 9 hours, we brought it down to less than an hour, just making these choices and then having smaller workers and things.
Yeah, so in our case, there was a migration from Mongo to Postgres. So document-oriented non-relational schema to a relational schema. So the bottleneck there was obviously, like, one bottleneck was we could read oplog from Mongo only once. So there you cannot parallelize that, right? So that's a serial operation. You can only read oplog from one Go routine. After that, you could parallelize that and say, hey, I'm going to now spin up n number of, we have n databases. So for each database, I'm going to have a Go routine and a channel. And for each databases, each collection in Mongo, I would have one more. So if there are n databases and m Go routines, you would have n into m channels and Go routines, like that kind of combination. So you could achieve the parallelization over there, but then ultimately, again, when you are pushing data to Postgres, you would again have to fan in, because there's only a single database, a single Postgres as an instance. Well, there are multiple databases that you would create and multiple tables. So what we ended up doing in our case, what we ended up working for us is one sort of connection pool per database. and then with that connection pool, we would write to Postgres.
Interesting. Any questions, thoughts, feedback from the audience? Please raise your hand. I'll make it as interactive as possible. Somebody's raised their hand, trying to either sleep and quietly slid it down. Okay. So, I'm actually switching gears. We've spoken about performance of applications. We've spoken about scalability of data, the pitfalls, issues with cores, go routines, channels, different kinds of storage. But ladies and gentlemen, performance and scale is also a factor of people, organizations, structure. In your experience, and you all have now had that experience not just with tech, but also with people, what is the importance of having a performant team? Point in question, Prerath already mentioned that founding engineers are interns. I'm pretty sure that will not be the case with at least one of the three of the other panelists. What kind of a team would you call as a performant team? Open to anyone to pick up that question.
I think you need to first focus on the problem, right? Having a huge team does not make sense. So at least in my case, we used to max have like 2 people trying to solve the problem. And I'll also touch upon another point, and you said non-tech and then business side of things. I think, going performant or reducing the time is like something which engineers always want, saying, okay, let me bring it down from 40 minutes to 20 minutes, 20 minutes to 10 minutes, and so on. But the point is we should also focus on what kind of business value it will really drive out, right? So let's say if I said we moved it down from 9 hours to less than an hour, we could have thrown, let's say, 8 more cores or 16 more cores and brought it down from 40 minutes to 20 minutes as well. But in our case, the value it would have added, it would have obviously added the cost, but the value it would have added, and maybe adding in more people, this is not something we could justify to the business. Let's say, spend, let's say, $1,000 more, you'll reduce it maybe by 10 more minutes, right? Because we have optimized it to a certain bit. So I think that is where having a smaller team actually helps. And I never got a chance to work with interns in that sense, so I'm not sure how that would work. But someone who understands the problem well and can divide the problem into smaller chunks and modules is what I feel as the best performing team.
So I have a little bit of harsh take, okay? So our migration was completed by just 4 members, okay, including me, so 3 other than me. So in my perspective, a highly performant team is non-remote team, okay? So we booked an hotel, and we just, all the people just like today, we came under the one roof and we started working. So our half of the team is in Redmond, San Francisco, and half of the team is in India. So so we worked in rotations, okay? So once we had our take, we did some benchmarks, we did some bandwidth analysis and other stuff. The other team took another step to work with Golang. So having teams across different time zones and also non-remote teams for startup like ours helps a lot, okay? Similarly, Google's SRE practices works in the cycle. So once the case is transferred from one team to the other, as the follow the sun rotation, as we say. Yeah.
How many people here practice pair programming? Okay. And it's part of extreme programming. Now, there are 2 types of pair programming. Either you have peers or you have a mentor and mentee. Do any one of you all work with a mentor-mentee model or peer model?
So in my company, we have around 15 odd guys in tech and around 150 plus in sales, right? So why we want to have a less tech team with the the maximum output is we want to have it. We don't want to build our OpEx very high. Now, having a good team is, it is mandatory, because if you have, if you increase the team and obviously they will have the problem. And being a bad boss, my hiring is always says that you have to come to the office. If anyone stays that I want work from home, I said sorry, this is not the company you should look at. Because the ideology is you come to the office, you will exchange some of the ideas, you'll get to know the business impact. Because see, somebody who is sitting outside at home, he might not be aware of the business situation. Suppose something goes down or if there's any production error, he'll be sitting there and he don't have an idea what is the impact on the business, right? But if he's in the office, he will see the rush, right? If people will start coming to him, "Arey, ye fad gaya hai," fix it. So I feel, that is what, we should look at.
So I think from a original question of high performance team, right? A lot of factors come into picture. I mean, people have been trying to measure software productivity and that for decades now. So I won't go into that area. But a team where there is less communication barrier between each other, that is a very high performance team in my, that's what I've seen in my experience, where when you say something, someone just gets it, right? Whatever that means in your context. Typically it would mean you have more business context, you know which part of the code to touch and modify, you know the failure modes of the system, you focus on rigorous practices like pair programming, even test-driven development in some cases, you debug things together, things like that, right? So a team that who does this and who's constantly trying to improve and learn is usually a high performance team.
What about some experiences from the audience? Who'd like to share something about the good points or the bad points of working in a smaller team or a larger team? Especially I'm pretty sure there'll be certain people who are managing teams. What's your take? Post-lunch zone. Yes, ma'am. Wait. We'll get your mic. Hold on.
Yeah, the major problem that of collaboration and communication is definitely going to be challenging. Make sure that everybody are on the same stage, right? In terms of development, in terms of what is the business objectives. So that's where I see, yeah.
So have you enjoyed working or managing a larger team or a smaller team?
Managing smaller team is where if the impact is huge and if you had to deliver it, yeah, definitely. So, but at the end of the day, it's all with the, the way we are delivering it, how we can make sure that we can componentize and then come up with the, smaller modules which can be delivered, right? It should not be the place like where should be a one single solution. It should be always in incremental fashion.
Nice. And quickly asking you prefer remote teams or working together?
Yeah, we are hybrid.
Okay.
Yeah, we do encourage people to come to office, collaborate.
Hybrid means you work together sometimes and work from home sometimes.
Yes.
Okay, cool. I think we had a couple of hands raised here too. Could somebody help with the mic, please? That's called cutting to the chase first.
Hello. Yeah, so my name is Vishal. I'm from PubMatic. I manage a core team. Now my team has grown, but a couple of years back when we had acquired another product, our team had only 3 to 4 members, including me. It was very easy for us to manage the team because I wasn't looking at it as if I am managing it. Every individual had its own ownership and everyone were feeling responsible about that. But the moment we started growing, we went global, I think last year itself, on our product. It was only restricted to US business. And then when we decided to launch it globally, our responsibilities increased. We got exhausted easily. So we had to increase the team. That's when I started struggling, maintaining that team, managing that team. So we had to take help of Agile to implement the Scrum, all those things. But that has at some level slowed down the process or slowed down the deliveries also. But yeah, I mean, we were confident that the deliveries were robust. So that also helped. But again, coming back to how I enjoy or where I enjoy is working with small core team, wherein everyone feels responsible and they take the ownership of the product as if it's their own product.
Right. So smaller teams, quicker progress versus larger teams and more process-oriented approach.
Yeah.
Both
The
work.
Another
Preferences are
viewpoint is
changing.
smaller teams. When we need that is from a survival perspective. We want to go live globally. Make sure that a bare minimum version of that product is running with limited features. Yeah, that's where smaller team works. At its max productivity. But yeah, when it comes to like sustenance, increasing the robustness of the product and making sure to introduce more features to grow the business, yeah, it is very hard for smaller teams then.
Nice. And quickly again,
I have
remote
one more question,
or
sorry.
Remote or non-remote?
Hybrid.
Hybrid. Okay.
I have one question actually to Prerath, if I'm not mistaken with his name. You mentioned about like, with increase in number of cores, you have identified performance overhead, right? Our product is CPU intensive as well as time intensive. So we were not sure like, how performant we can make our pods in Kubernetes with now combination of cores and memory. But we played around that, we found out that the moment we shrunk the pod sizes in terms of CPU cores and memory, it started getting so much performant. But do you have or is there any such guideline which will specifically tell us to how can we maximize the performance at pod level?
Okay, pod level. You're talking about Kubernetes, right?
Sorry?
Kubernetes pods.
Yes, that's right. Kubernetes
Okay,
pods.
so the first thing is to maximize performance, make sure that CPU's limits, and there are two resources, right? CPU and memory. So make sure that there is no limit set on CPU. Okay, else like there is a problem of noisy neighbor, right? So just make sure that memory request and limits are same, but there is no limit on CPU. Only requests. So in that case, there will be no noisy neighbor and other stuff. So one point about non-remote teams. Okay, so actually this is real story. So one of our interns, we gave him our company's resource. Okay, the laptop, and we were tracking everything like every company does. So what he was doing was that his laptop was at his home. He took the RDP access of that Windows machine, and he was working from hillside. Okay, and he was pretending that he was working from home. Okay, and so this is some downside of working from like believing the employees and just believing them. Okay, so these are very unique ways where they can lie that his laptop is at home but he's taking the RDP access and then he's working from the hills. There's no point in lying, but he must have said truth. Okay, yeah.
Call him to your office, give him a raise. Because if you're smart enough to actually set up so much of infrastructure to ensure that your laptop is powered on, the RDP is functioning with redundancy, with electrical redundancy, internet redundancy, then you're working from the hills, connecting on a low latency network over whatever your phone or probably another laptop. The dude, make him a network engineer and give him more responsibility, I say.
So actually, we didn't fire him. So he's our engineer one. No, he's not here. So he's working from the hills.
Might do a talk from the hills as well.
So I think we had a question. Oh, we have questions.
Yeah, hey. Zen, I work for Bandhan Bank at the moment. My experience, I think it's across, it's not for Bandhan or any specific place, but across, you're able to hear me, right? Okay. So experience so far with larger versus smaller, what I would say is larger working like a smaller team, right? So I'll explain what that means. Sort of you've got to divide them up into pods, make sure that their goals and responsibilities are very, very clear, right? And then they're empowered, right? So it's not about individual people, it's about the culture of empowerment. That's what I feel, right? And so that culture kind of has to permeate throughout the team, right? They've got to know the importance of what they're working on. They've got to know what we're trying to achieve, and then that's how normally you have very high performing teams. That's what I've seen. And to answer your question
just to continue that particular point, Zen. So what Zen just mentioned is that you break up larger teams into smaller teams with single responsibility. That is actually, we were having this intense discussion yesterday over Beer++. And the discussion was about microservices versus monolith. And this was an intense output which came out there. That microservices has nothing to do with technology. Microservice is to do with teams. Larger teams split out into smaller teams having single responsibility. That's actually the true microservice architecture. So, just to complete.
Yeah.
Sorry, your next question.
So next point was, so I think you were asking about hybrid versus office versus work from home. I think so far my experience has been work from office is better for innovation. So when you want to spitball something, you want to work out a solution for something, definitely better to have everybody on the same place. So even my teams were in the past, whatever we used to do was either all are at home or all are in office. There's no kind of this thing. So that's how we used to do it. Right? So maybe 2 days at home, 3 days office, something of that sort.
Yeah, I think hybrid, as Shailesh was mentioning earlier, is a post-COVID term.
Yeah.
Right. Thank you, Zen. Yeah. Yes.
Hi. So you spoke about having the question is highly performant team, right? So that is again vague in a way, because what do you mean by performant, right? So when the panelist ended up taking the question, so we usually face this conundrum: speed of execution or delivery versus quality of delivery, right? So I'd want the panel to, how do you get to decide, or how do you get to take a philosophical stand, right, for the team when you're leading a team, right? So when it comes to aligning yourself with the business goals, so can the panel take that question?
So is quality of the deliverable?
Yes, versus the speed.
Versus the speed.
I think at each stage of the company, and depending on who you talk to, the answer, their trade-offs will be different. So for example, in a 0 to 1 case, you'll probably optimize for speed of delivery than quality, because you don't know whatever you're building, whether actually it'll be even used by users or not. So you want to put something out there, iterate faster. So the focus is on speed of iteration in that case. But the caveat there also is that if you just optimize for speed, over time, the quality of the code degrades, and therefore you can't do faster, right? So there's that problem. So essentially at an early stage, typically people optimize for speed. As you become more 1 to 10 to 100 kind of stage, you want to optimize your stuff. So that's where the focus on quality of engineering, quality of test cases, confidence in the code, ability to roll out safely, know that this will not fail, all of those things matter. Therefore, the focus on quality and optimization and efficiency matters at that scale. That has been my personal experience.
I agree with what Chinmay said. So trying to over-optimize from day one has not been the very best approach, at least for my case, right? So if you spend, let's say, 6 months and you're not able to even get to the market, get to the hands of the users, that kind of takes a hit on the business. So the example which even I took, right, we reduced the time, let's say by 90% or so. That whole system worked for 12 years because we never hit the scale where we had to optimize it further. So till the time you do not face the problem, I think it should not be very bad that it doesn't even work tomorrow, but it should be in a certain state where it works and it can make you survive for a certain time, and then you can invest more into that. But trying to over optimize from day one, or thinking what will happen if I get 1 million users when you have like 100 users coming in tomorrow, that does not help in most of the scenarios, at least from my perspective.
So quality or speed? So quality or speed?
I would say speed in the beginning.
+1.
+1. My take is slightly different. I actually disagree. I just say I will always focus on quality. Even if things are getting delayed, whether you are running a product, whether you are running a service, whether you are running towards a timeline, whether you have a pesky customer, whether somebody who's going to hold a gun to your head, you focus always on quality, even at the cost of a delay. The only thing you have to keep in mind is no stagnation. You can't stand still. You have to keep moving towards quality. You may drop, you may rise, but you have to keep moving. Quality comes first.
So I think the question is the speed at what cost, right? Now, obviously, as a business, everyone needs that, okay, if we have this requirement, we need this yesterday, right? Every business will have this the requirement. But then if you have the right checks and balances, like you have a CD pipeline in place, you have the deployment, you have the test cases, even when you're doing a PR review, the reviewer makes sure that the test case has been written. In my personal opinion, we are good to go. Even though you may not look at the way the code is written, it might not be 100% optimized, but it should be ready to go on the production and it should not break the existing code. And then, as and when we have the requirements, I mean, obviously, if it is written in the bad way, you will face the latency or the issues at some point of time, where at that time you can look at it.
Thank you.
Interesting debate. Actually, you actually asked a question which has sparked a debate. Good stuff. And we have one more opinion. The mic, please. I'm assuming, Ayush, that's an opinion, not a question.
So yeah, I am Ayush from PubMatic. So on your point, Gautam, like you said, like for you, quality comes first. So just had some view on that. Yeah, quality is there, but at the cost of timeline. So let's say you tell your team, like we need to work on that, but quality is something which can always be refined. So nothing is perfect, correct? So we need to have some boundary, like this is something, this is good enough, or like some numbers to it. Like if your code is doing, let's say 2000 QPS, 3000 and whatnot, like then it's good enough, it's performant enough. And maybe in the code review cycle and all, like you are making sure like all the maybe Go standards, Ruby standards are handled, then it's good enough. Because I believe like quality is something which can always be improved. Like maybe today, tomorrow, there will always be changes in the software. So yeah, I think having a timeline, a boundary to what we mean by a quality, some standard guidelines to it. So I think
either ship fast or ship right. Somewhere in the middle.
Yeah, something like that. Yeah.
Right. All right. Any last thoughts? All right, panelists. All right, last thoughts then. So while our mic reaches her, I'd like you all to prepare one liner or one sentence or one word or very quick takeaway for every individual sitting here related to how to be either performant in your own way. How to be performant in your own way. Yes, ma'am.
Hi, I'm Anubhuti from ConnectWise. So in my opinion, and you guys, I'll like to hear your opinion on this. I feel the kind of quality that's most problematic is when it's not in the culture, not the kind of things you go for in terms of database or something in the beginning. It's more like if it is not in the culture, your developers are not with that mindset, then that's the kind of quality that becomes most problematic in the long run. Especially if you go for something as a POC kind or just to hit the market and feel the waters, and then you get a staggering response and suddenly you are not having that bandwidth to actually go and correct everything. Maybe you can go for that reevaluation of your choice of database and architecture and all of that. But again, I feel quality is more required in the culture than how you're designing things. So there's another question that I have is, so we talked about single responsibility, that when we are splitting our monolith services into microservices, we have single responsibility, but somewhere I feel that there is a loss of shared vision if that is not driven by the I would say mostly from the higher ups. So how do you see that in a big company where you have multiple microservices, how do you retain that shared vision across microservices, across teams? Because then you integrate microservices, right? Different microservices are consuming different others, and then if there is a bad integration, you end up in a situation where probably nobody is looking at how it is going, and you run into a situation that you have to again reevaluate all of the integrations that you have.
I think the whole idea is that the way the microservices have been designed at the first place seems a little wrong, right? Because if you're saying that this is a microservices just doing one thing, and then there's a lot of communication going on between one and the other, then I think looking at the actual design, and that makes more sense. How I see it is more of like, we call it as macro services, right? Because we say, give a responsibility to one service, but that's the only thing they should be doing. If it is talking to a lot of other services, then better be in a monolith. It becomes easier than managing all these communications.
So I like the 2 points you actually brought up. One is you have given a big thumbs up for quality coming first. Second is you're asking about the microservices from a team structure as well as from a product perspective. Microservices fail. That's the whole intent of microservices. But when a monolith fails, it's like a whole organization fails. So when a microservice fails, it is the responsibility of that team, that department, that service or that product to actually be resilient and come up again. But that's the single responsibility principle. If a core service fails, it affects everyone else. So not knowing the bigger vision or the bigger picture or the reason why you have built this particular service and not knowing that reason is a problem. So while all the microservices as part of a team or product work together in unison, your product is going to succeed. So knowing everyone's responsibility is equally important than saying, I did my best, I can't help when others failed. I hope that answers your question.
It does. So maybe from you all, how do you in your companies try to drive that, keeping that vision and keeping in, just being in control of that, you do not end up in a situation where your microservice becomes like a monolithic failure, because some core service that you have, everybody is integrating, everybody integrates strong, and then everybody starts killing your core service. So how do you as leaders of your organization, or how do you manage that?
May I just answer that quickly? One liner, clarity of vision. Everyone in the product team, your sales team, your customer success team, your DevOps team, developers, QA, everyone must have that clarity of vision. This is our purpose. If that purpose is clear, all your microservices will always be performing towards that one particular vision. If that clarity of vision is not there, it's a recipe for failure, either sooner or later.
Thank you.
All right, I think we got a lot of clarity. So, any last words, final words, panelists?
I think focusing on the actual bottlenecks is what helps you being performant.
So the question was to how to be performant, right? So have a goal. That's it.
Probably one more point I want to add is keep your eyes open, because the tech is changing so fast, and probably the tech which you are using in your product might be an old, there are a lot of different things coming every day, every month. So you have to keep the eyes open. You should know what to choose. That should increase your performance.
Fantastic. Thank you for being an interactive audience. Really appreciate it. Thank you, panelists. Thank you so much. A loud round of applause for them, please.